Good evening, everybody. I apologize for the strange light above my head. You will just have to imagine that I am in haloed. Okay, so I wanted to make a quick video about polynomial long division. And the reason that I wanted to do this as a video is because it's not the type of topic that you can necessarily follow very well in real time if you haven't seen it before. And I think actually that in video form, it may be better because you can stop, you can try it as you're going along, you can go back, because it feels quite tricky at first. If you haven't seen it, it feels quite tricky. So what are we talking about here? Well, we're talking about a rational function of this form. You have to excuse the beeping behind me as well, of this form, which is not in what we call proper rational form. Okay. Now remember, proper rational form is a rational function, i.e. one polynomial divided by another, where the order of the polynomial on the top is strictly less than the order of the polynomial on the bottom. Now that's not the case here. The order of the polynomial on the top is fifth order, and the order of the polynomial on the bottom is second order. Okay. Now we can think about this in the same way that if we have a fraction, here I've got 350 divided by 23, okay, I can ask the question, can I write this out as some integer plus another fraction, okay, equals some integer plus something divided by 23, where this thing is less than 23. Okay, we're going to be doing the equivalent thing, but here for polynomials. So in this case, what would we do? If we want to do 350 divided by 23, well, what's the first thing that we would do? Well, we would see how many times 23 goes into 350, sort of entirely into 350. Okay, and you can fit 23 into 350 15 times. Okay, but if you try and fit it in 16 times, well, 16 times 23 is greater than 350. Okay, so that is to say that 23 times 15 is 345. Okay, and if we try to do 23 times 16, that would be 368, which is greater than 350. 350. Okay, so just move that down here. So what do we do whenever we're doing just regular long division? We take the number at the top and we multiply it. We take this number now and we multiply it by this, and then we subtract. So this gives us 345, and we subtract 350 from 345, 345 from 350, and that gives us 5. Okay, and now 5 is less than 23, and we're done. Okay, so what this tells us is that 350 divided by 23 is 15 plus 5 over 23. Okay, and you can show that that's true by putting everything over a common denominator. So this would be 15 by 23 plus 5 over 23. And we know that 15 by 23 is 345. So this is 350 over 23. Okay. Make sure that you can do regular long division before you start looking at polynomial long division. Now, we're going to do the same thing here, and we're going to do that for a polynomial, a rational function, I should say. So let's look at this. I'm just going to paste it up here again. Okay, and we're going to do it in exactly the same way that we would do for a regular fraction. I'm going to put in here the polynomial in the numerator, but I'm going to make sure to include the zeros in front of terms which don't appear, and I'll explain what I mean in a moment. That was a bit unclear. So we've got x to the fifth. We've got no x to the fourth term, so I put in plus 0x to the fourth plus 0x cubed minus 3x squared plus 2x minus 7. Okay, so I've got a term there for every power below the x to the fifth. Okay, and then I put in the x squared minus 3x plus 2 over here. Okay, so what do I see? I've got a fifth order polynomial here. Okay, and I've got a second order polynomial here. Okay, so I can ask the question, if I've got a fifth order polynomial and a second order polynomial, how many times does x squared go into x to the fifth? Okay, well, x to the fifth divided by x squared is just x cubed. Okay, so I look at the highest powers here and here, and I ask how many times does this go into this? And the answer is x cubed times. So I put an x cubed here. I put an x cubed here. Okay. Now I do the same sort of multiplication that I did up here, where I took 15 and multiplied by 23 and ended up with 345. Okay. I do the same thing. So the x cubed I got from saying, how many times does x squared go into x to the fifth? And the answer is x cubed times. That is to say that x to the fifth divided by x squared is x cubed. Okay, so that's where that comes from. Okay. So now I multiply the x cubed by the whole polynomial on the left. And what do I get? Well, I get x to the fifth because I have x cubed times x squared, but I also have minus 3x to the fourth. Okay, I've got x cubed times minus 3x gives me minus 3x to the fourth. And then I've got x cubed times 2, so I've got plus 2x cubed. Okay, I draw a line in, and now I subtract this from this. Okay, what does that give me? Well, x to the fifth minus x to the fifth, that's just 0. 0x to the fourth minus 3 minus 3x to the fourth gives me 3x to the fourth. 0x cubed minus 2x cubed gives me minus 2x cubed. And then I've got no terms after that here, no terms after that here. And so we're just left here with minus 3x squared plus 2x minus 7. Okay, so all I've done here is I've taken this and I've subtracted this from it in the same way that I did here. I took this term, I subtracted this, and I ended up with 5. Okay. Now let's do the same thing. How many times does x squared, the leading term here, go into 3x to the fourth? Well, the answer is, and I'm just going to put it here, plus 3x squared. Okay, if I do 3x to the fourth, 3x to the fourth divided by x squared, that just gives me 3x squared. Okay, so now I've got 3x squared up at the top, and I do the multiplication again. 3x squared multiplied by the whole of the polynomial on the left gives me 3x to the fourth. So I'm doing this term here, okay, times this here. Okay, 3x squared times all of this. Okay, so it's going to give me 3x to the fourth minus 9x cubed, 3x squared times minus 3x, plus 6x squared. And again, I do a subtraction. What do we get when we subtract the second line, the bottom line from the one above it? Well, the 3x to the fourths disappear. Okay, I'm going to get minus 2x cubed minus 9x cubed, which is 7x cubed. I'm going to get 3x squared minus 6x squared, which is minus 9x squared. And then I've just got plus 2x minus 7. We repeat. Okay, now I've got the 7x cubed here. The highest power here is x cubed, and I've got the x squared here. Okay, so I have plus 7x, because 7x cubed divided by x squared is just 7x. And again, I multiply 7x by x squared minus 3x plus 2. And I get 7x cubed minus 21x, which is 7x, squared. 7x times minus 3x plus 14x. Does that look right? Yes. And again, I subtract. 7x cubed minus 7x cubed gives me 0. Now I've got minus 9x squared and minus 21x squared. That's 12x squared. Okay. 2x squared minus 14x squared, 2x minus 14x gives me minus 12x and minus 7. Okay, we're almost done. Not quite, we're almost done. Okay, so I do the same thing again. 12x squared divided by x squared gives me 12, just the constant 12. Again, I multiply everything through, gives me 12x squared minus 36x, 12 times minus 3x, plus 24. And I do the subtraction, which is going to give me 12x squared minus 12x squared. They cancel. Here I've got 24x. And here I'm going to have, what's that going to be? Plus, minus 31. Oh, x minus 31. Okay. So what does this tell me? Okay. This tells me this term here, well, very importantly now, okay, the order of this is now less than the order of this. And in the language of what we had before, this term here is less than this term here. We're not talking about orders here. This term here is less than this term here. This polynomial here, the order of it is less than this polynomial here, so we stop. Now we can say that this original expression that we wanted to calculate is equal to x cubed plus 3x squared. I'm just taking this line here, okay, plus 3x squared plus 7x plus 12 plus 24x minus 31 divided by x squared minus 3x plus 2. Okay. And if you want to check that this is true, that this does indeed work, you can take this term, you can multiply it up by this, okay, and you can see if it does indeed give you what you expect. Okay. Actually, let's just do that. Okay. Well, we're not going to do that explicitly. I want you to do that. But what I do want you to see is, let's look at the highest order terms. If I take this and I multiply it by this, the highest order term is going to be x squared times x cubed, which is why we have an x to the fifth here. Okay. X cubed times x squared. What about the lowest order term? Okay. It's going to be 2 times 24, but we don't have 24 here. But we've got to remember, we've got 2 times 24 minus 31, which is indeed minus 7. Okay. You can work out that the x squared term here is going to come from two places, actually 3 places. It's going to come from an x squared times 12. It's going to come from a minus 3x times 7x, and it's going to come from a 2 times 3x squared. So there are going to be 3 contributions there to the x squared term. The 2x term is going to come from the 3x times 12 and the 2 times 7x. Okay, just go through and make sure that indeed that does give you, when you multiply it all out, the right expression on the top here. Okay, so this might seem like a lot of work, but it's one of those things that a bit of practice, and you can make up any examples you want, and I recommend that you do. Okay, challenge yourself, make up an example, go through it, and then the beautiful thing is that you can check at the end whether indeed you got the right answer by multiplying everything through. Okay, I'm going to stop there for now. Please message if you have any questions, and I'll see what I can do to clarify. However, just make sure that you go to the resource book and you look there at the section on polynomials, because there is a long description there about precisely where this polynomial long division comes from. Okay, it might seem a bit like magic at the moment, but there's a very good reason that we're allowed to do this. Okay, the procedure that we're doing here is well founded. We haven't just sort of made it up. Okay, there's a good reason for doing it, and it's quite a long explanation in the resource book, but I think that it gives a good intuition as to why we're allowed to do all of these steps, and it should give us the right answer in the end. And by the right answer, remember what I mean is writing a polynomial which is not in proper rational form, the order here is higher than the order here, writing it in terms of a polynomial plus a rational function which is in proper rational form. Okay, we've still got the x squared minus 3x plus 2 on the bottom, and on the top we've got something which is one order lower in this case. It could have been it might have been that we didn't have the x, but it's a polynomial which is of lower order than 2. Okay, very good. I'm going to stop there. Let me know if you have any questions.